Welcome back. This is the second lesson recording for IM2, November 2nd, 2020. So I'm just going to go through this problem again. Okay, so first of all, thing you should recognize is that we do have 45, 45, 90 degrees triangle. How do I know that? Because we have an isosceles right triangle. Okay, a right triangle with isosceles the two sides, two legs being equal. It's an isosceles triangle. That means this angle, the two base angle needs to be 45 degrees. And we've figured out that to go from the leg to the hypotenuse, you need to multiply by square root of 2. Okay, but this time we know the hypotenuse length and we're trying to figure out the length of the leg. So if we know that to get from the leg to the hypotenuse was to multiply by square root of 2, what do you think we need to do to get from hypotenuse to back to leg? Okay, so we're doing opposite. So what is opposite of multiply by square root of 2? It's actually divide by square root of 2. Okay, so we are going to divide square root of 16 by square root of 2. Okay, so to get leg length, divide hypotenuse length by square root of 2. So that means we're dealing with 16 divided by square root of 2. Okay, now remember, we do not want the radicals as a denominator. Okay, so we want to rationalize the denominator. How do we do that? We've learned how to do that last lesson. We multiply by a giant one that is formed by the radical that is in the denominator. So that's going to be square root of 2 divided by square root of 2. The denominator becomes 2, and the numerator becomes 16 root 2. But since 16 is being multiplied to square root of 2 divided by 2, 16 divided by 2 is 8. So the final answer is 8 root 2. So we know the leg is 8 root 2. Okay, and if we know one of the leg to be 8 root 2, we also know the other leg to be 8 root 2. Okay, so then I would like you to go to the rest of the class. So that's going to be 7 to 10, where you are going to use that, what we just discovered, to figure out the side length of the 45, 45, 90 degree triangles. Okay, here you go. All right, so we know we're trying to figure out unknown side length. Okay, so we know that this is a 45 degree and a right angle triangle. So that means we know this angle has to be 45 degrees also. And if that is the case, we're dealing with 45, 45, 90 degree triangle. That means whatever the side length of the leg is, V is also going to be the same because they are going to have the same length because it's isosceles triangle. So that is going to be the length of V is going to be square root of 2. Now the length of U, okay, what do we need to do to get from the leg to the hypotenuse? We said that you need to multiply by square root of 2, right? So then whatever U is, that's square root, V is square root of 2. What's square root of 2 multiplied by square root of 2? So square root of 2 times of V, U is square root of 2 times square root of 2, which is just 2. Because that's square root of 4, which is same as 2. So it's just going to be 2 there. Okay, what about this? This time we know the leg to be 4 root 2, and it is a 45, 45, 90 degree triangle. What do we know about B? It's going to be the same. Okay, the B is, they are going to have same measure. Okay, so B and both the legs are going to have same measure. So that's going to be 4 root 2. Okay, and we also know that to go from the leg to the hypotenuse, you need to multiply by square root of 2. Okay, so that means 4 root 2 multiply square root of 2. 4 root 2 multiplied by square root of 2 is going to be 4 times square root of 4, which is same as 2. So that's going to be 8. So A is going to be 8. And length of B is, we said, was 4 root 2. Okay, what about number 9? This time we know that this is still 45, 45, 90-degree triangle, but we know the hypotenuse. So remember, up to now, we've been doing, to get from the leg to hypotenuse, we multiply by square root of 2. Okay, to go the opposite direction, to go from hypotenuse to the leg, we need to reverse, undo, multiply by square root of 2. What is opposite of multiply by square root of 2 is divide by square root of 2. So to figure out B, it's going to be whatever the hypotenuse is, which is 8, divide by square root of 2. Okay, and now we don't want the denominator to be radical. So we need to multiply by square root of 2 over square root of 2. That becomes 8 root 2 divided by square root of 2 times square root of 2 is square root of 4, which is 2. So but this time, 8 is being multiplied by root 2 divided by 2. And so we can divide the numerator by 2 and denominator by 2. And you're left with 4 root 2. So the B is 4 root 2. And we said A was same as, always same as B. So if B is 4 root 2, A has to be same as whatever B is we found to be. Okay, so it's going to be 4 root 2. Okay, and the last cut. Okay, this time we know the hypotenuse is 10 root 2. We're trying to find x and y. Okay, so what do we need to do to go from hypotenuse to the leg? We divide by root 2, right? Because we know that to go from leg to hypotenuse is multiplied by root 2. So to go from hypotenuse to square to leg is divide by root 2. Okay, and perhaps you're thinking, oh, what is root 2? Well, root 2 is actually a good number that you might want to remember. You are multiplying by 1 point, approximately 1.4. Okay, so you know that this is going to be something bigger than by a factor of about 1.4. Okay, so then let's just do, so we're going from 10 root 2, and then to go to the leg, you're dividing by root 2. Okay, remember divide and fraction line, that means the same thing. Square root of 2 is being multiplied by 10, but then divide by 10 to square root of 2 again, so that leaves me with just 10. So we have just figured out y is 10. And if y is 10, x and y are going to have exactly the same measure, so x has to be 10 as well. Okay, now you're going to go on to card number 11 to 19 of the Desmos, and we are going to be exploring a different type of special right triangle. Okay, so exploring a new type of special right triangle here. Can you figure out all the right angle measures, label them in? How do you think the names of this special type of right triangle? Right now, we only know the hypotenuse is 2 units. Don't do much about the length of the 2 legs. But next card has a trick that can help. Okay, so if you know this is 30 degrees, what else do we know? We know 30 plus this angle needs to add to 90 degrees, so this has to be 60 degrees. Okay, so we do know that. Do we know anything about the legs? Well, no, because we need to figure out, no, at least two legs to use the Pythagorean to figure out the other leg's length, right? So this is as far as we can go for now, but next card actually gives us a clue. Okay, we made a reflection of our special triangle. Okay, and we can call that as a 30, 60, 90 degree triangle. Why? Because we have 30 degrees, 60 degree here, and 90 degree triangle. So then go ahead and label all the angles and all measures you know in the reflected triangle. So we just basically reflected exactly the same triangle onto the other side. That means by definition, this has to be 30 degrees, this has to be 60 degrees, and this length has to be 2. That's by definition of reflection. Okay? All right, so then do we know of anything else? Well, look at the angles. This is, what sort of angle is this together? That's going to be 60 degrees altogether. So we're dealing with 60 degrees. If you're just looking at the big triangle, we're dealing with 60 degrees, 60 degrees, 60 degree triangle. We call that equilateral triangle, okay? Because all the angles are the same. If all the angles are the same, what do we know about the side length? The side length also has to be the same. So if this is 2 units, this is 2 units, that means this has to be 2 units. Okay, so the total length here has to be 2 as well. Okay, but what do we know about these two triangles? They are congruent, right? That means whatever this measure is, this is also going to be the same as here. So if they together are 2 units, then this has to be 1 unit here. And this has to be 1 unit here as well. Okay, so I'll write it down here. Okay. All right, so this just sums it up what we have found, okay? Now, can we figure out the height of this triangle, the height of this equilateral triangle? Well, if we figured out this has to be 1 unit, this has to be 1 unit, then using the Pythagorean theorem, 2 squared, that's 4, so 2 squared, so this is the hypotenuse. This is hypotenuse, and this is one of the leg, and this is another leg. If I was to just try to visualize just a right triangle. So that means to figure out what this is, we can say that x squared plus 1 squared, that's 1, is 2 squared. So that's 4 is equal to 1 plus x squared. So bring 1 to the other side and you're left with x squared is equal to 4 minus 1 is 3. So x is square root of 3. That's how I've got my square root of 3 there. Okay, explain why they're late. Okay, so we've already talked about that. All right, so let's use the similarity ratio to find the measure of the bigger 30, 60, 90 degree triangle. Okay, so this is the most basic right angle triangle. That's 30, 60, and 90 degrees. And those two triangles, the 40, 45, 45 triangle, and this one, I am going to ask you to memorize. Okay, so how do you draw this? You draw a 30, 60 degree triangle, and with the short side having 1, the hypotenuse having 2, and the third side is going to be square root of 3. Okay, so then write down below what you think h should be. H should be, okay, what did we do to get from the short side to the hypotenuse? We multiplied by 2. The ratio is 2 over 1 or multiplied by 2. That means I am going to multiply by 2. So the h is going to be 13 times 2. That's going to be 26. to get from the short side to the longer side, you multiply by square root of 3.